All right, we're going to graph a rational function. All right, y equals 4x over 2x minus 3. There are two ways to do this. You either can identify the horizontal and the vertical asymptote from the rules, probably like you did last year, where we say, hey, we know the bottom can't be 0. All right, and if I do that, do we all agree we get 3 halves? So the domain is easy. X is an element of reals. X does not equal 3 halves. All right. The range is quite a bit trickier unless you know the rule. All right. That when you have equal order on top and bottom of a rational function, that the coefficients will give the horizontal asymptote. And the horizontal asymptote this time is 4 over 2 is 2. So we know that in the range, y can't be equal to 2. So again, y is an element of reals. Y can't equal 2. All right. Now, I have to make my sketch. All right. X. Here's 2. Here is 3 halves. And often I plug in 0, guys, up into the original function. When x is 0, what point do I get? This time I get 0, 0. So I will plot that point so that I realize that coming off the asymptotes, the curve looks like this time, my reciprocal function, approaching the asymptotes. Now, I could do the positive and negatives, but I've graphed enough of these to know. But again, I typically don't do it this way. I typically do it this way. I will do polynomial division. All right? Because we don't know if it flips until you do polynomial division. Sometimes they end up in the other quadrants. All right? And I will do polynomial division, and I will write my function in the standard form. All right? Where the 6 over 2 becomes a multiplier of 3 to stretch it. And again, I can see the shift here. It is shifted 3 halves to the right, up 2. And that way I know my graph is correct. I almost always do these things by polynomial division. Either method works, all right? Graphing a rational function, find its range and domain. All right?